All right, in this video, we're going to talk about one of the colligative properties, vapor pressure lowering, which is essentially that the vapor pressure of a solution is less than the vapor pressure of a pure solvent. Okay, so first we're going to conceptually explain why this is true, and there's two ways that we can explain this. One is by talking about dynamic equilibrium, which we'll do first, and the other is a more fundamental thermodynamic explanation. Fundamental thermodynamic, kind of bringing it back to one of your previous videos on the entropy of mixing and nature's tendency towards mixing. So let's talk about equilibrium first. All right, so when we defined vapor pressure, and I'm going to drop my beakers as rectangles here so that I can show that they are sealed. These are sealed containers. Okay, and I have a liquid in this beaker. So here are all my liquid molecules in the liquid phase. They're really close together, but have no long range order. Okay, and those are in equilibrium with some molecules in the gas phase. So these molecules had enough energy to move from the liquid to the gas phase. And for this particular substance, this is the vapor pressure at equilibrium, and equilibrium means that the rate of evaporation is equal to the rate of condensation. Okay, so rate of evaporation is equal to the rate of condensation. But now let's add a solute to this beaker, which should be the same size beaker, but I'm not an artist. Okay, so here's all my, now this becomes a solvent because what I'm going to do is add some solute particles in here. And now I have intermolecular forces existing between the solute and the solvent particles. And so what happens is that those solute particles, so I'm going to draw the same number of dots here in the gas phase for the solvent, those solute particles start to kind of pull these solvent particles from the gas phase back into the liquid phase. And so the rate of condensation increases. So the rate of condensation, left out a few letters there, is now greater than the rate of evaporation. Okay, and so the rate of condensation is greater than the rate of evaporation, and then eventually the rate of condensation will slow down until the two rates are equivalent again. But what will happen is that I'll have a slightly more concentrated, not concentrated, a slightly more dilute solution and a slightly lower vapor pressure here because those solute particles have kind of pulled these solvent particles into solution. Okay, so now I'm back to the rate of condensation is equal to rate of evaporation, but the vapor pressure is now lower than it was initially over here. Okay. So now I have equivalent rates there. Okay. Now, more fundamentally, we can think about this as nature's tendency towards mixing. So now let's put we're going to put two beakers open, okay, but in an enclosed container. So the beakers are together. They're open to their little system here, but they're closed to the rest of the universe. And in the beaker on the left, I'm going to put just pure solvent. And in the beaker on the right, I'm going to put I have my solvent and then I have my solution. I have my solute particle, so I have a solution here. And what happens, so you put these in their enclosed container, and then the pure solvent starts to evaporate, right? We're trying to reach dynamic equilibrium. This has some vapor pressure, and so the vapor pressure in the container starts to exceed the vapor pressure of the solution. So the vapor pressure in the container exceeds, so I'm going to put initially, the vapor pressure of the solution. So what does the solution do? Well, nature has a tendency towards mixing. And so the solution will start to mix some of those solvent molecules into solution. And so if I redraw this whole system, what I'll see is that I have what is essentially a more dilute solution and a lower volume of solvent. Because as that solution starts to pull solvent molecules into it, and so I'll increase the volume over here actually, but as that solution starts to pull the solvent molecules in, the solvent continues to evaporate. And so the solution continues to pull solvent molecules in to dilute the solution. And so this will continue happening until all the solvent, all the pure solvent is gone. And we are left with just solution that has a vapor pressure that is lower than the pure solvent.